Hey, this is Charlie Thompson, and this is the intro video for the intro video for the intro video for climate change. I know you've got a lot going on this week, so I'll make this snappy. So, climate change. I know you've got an exam this week. Because you've got an exam this week, I tried to minimize the reading and present you with a ton of videos. The climate change playlist has 101 videos. Might be too many, but there's some real gems in there. I made a bunch of quizzes from the videos. I think that's a better way of rewarding you for watching the videos. The videos have important content. If it has important content, you should be assessed on your understanding of it and given points based on your understanding. So that's what we're doing. I made everything for this chapter due Sunday night. So usually you've got some stuff due Wednesday and then the rest of it is due Sunday. For this week for climate change, everything is due Sunday because of your midterm that opens Wednesday and closes Friday. So this really, in a nutshell, is everything you need to know. We're looking at the temperatures across the bottom. Here we have temperatures for the last 800,000 years of Earth's history, and in blue, we have carbon dioxide concentrations in the atmosphere over the last 800,000 years of Earth's history. The two important things to note are that CO2 has varied naturally between about 180 parts per million and 280 parts per million. The current level, I think we're at 418, something like that. We haven't seen those levels literally in millions and millions and millions of years. And I was going to try to find a picture of New York as it appeared the last time we had this much carbon dioxide in the atmosphere. There were alligators and palm trees in New York. The climate was so much warmer and wetter that it was actually tropical. And many parts of the world that are now have continental climates with freezing winters because there was that much carbon dioxide. And we've done it again. The difference is in the past, it was natural. The current level of carbon dioxide is because of humans. So here we've got the last 1,000 years of Earth's temperature. You can see that it's slowly been decreasing right up to the Industrial Revolution. Here we have 1800. We started to pump carbon dioxide into the atmosphere, and temperatures have shot up. Climate change concepts for the whole chapter. You're going to see this again in the other videos, but I think review is a really good way to cement knowledge. So how do we know about past climates? The answer is proxy data. It's going to be stuff in tubes, or rather tubes of stuff, ice cores, tree ring cores, coral reef cores. It just happens that the proxy data is usually in a tube of some sort. So that's part of how we know about past climates. Why is climate change in the past? The short answer is Milankovitch cycles, astronomical variations in Earth's orbit. How do we know that climate is changing now? Because we're measuring it. The temperatures that we're seeing, the shifts in extreme rainfall, the melting of the glaciers, everything that we could possibly measure. You know, if you made a list, and later on in the chapter I'll show you, there's a nice figure that's got a list of like, if the climate was warming, what would we look for? How would we know? Well, you'd see warmer temperatures in the air and in the ocean and on the land. You'd see less snow. You'd see heavier rainfall. Everything that we're seeing is consistent with climate change caused by humans. How do scientists model climate change? With, as Dr. Catherine Hayhoe will mention in a later video, with the same mathematical tools that we use to develop things like satellites and airplanes and cell phones. They're models of physics. There's no political bias. It's just models of physics. How are governments and people responding to climate change? This is an incredibly important issue. For the most part, the governments really aren't. They are not doing a whole lot. Really, they're not doing nearly enough to stop climate change because of the money of the fossil fuel industry, in a nutshell. All right. How do we know about anything older than like 1850? There weren't thermometers thousands of years ago. So how the hell do we know? Well, we know because of proxy records. Proxy records are records of one thing that can tell you about something else. So it's not a direct measurement like a thermometer. You're directly measuring the temperature. Proxy records are tubes of stuff. They are tubes of stuff For example, ocean sediment that has plankton, gas bubbles in glacial ice, so tubes of ice, tubes of ocean sediment, tubes of lake sediment that can show us fossil pollen, growth rings in trees, mineral formations in caves, tubes of ancient coral reef. All of those can tell us what the climate was like in the past. Here we have a scientist displaying one of these sediment tubes brought up from the bottom of the ocean. This one has been cut in half. That's the way they analyze them. You know, you wouldn't be able to see it if it was still in the pipe that they bring it up from the ocean floor. So they cut it in half, and then they can actually count layers and actually date the organic material to find out exactly how old it is, and then you know what the conditions were like at that time. Here we've got more sediment cores. Here we've got an ice core. We've got this person drilling out a coral reef, some fossil pollen. I love that picture because pollen is amazing. I mean, it makes us sneeze in the springtime, but different species of plants have really different looking pollen, and the pollen itself is very rugged. It lasts a long, long time. It's identifiable as to the species, and so by looking at pollen in lake sediment, we know what the climate was like in that lake thousands and thousands and thousands of years ago because of the pollen. Causes of present climate change. So let's see. The black is what really happened, and the red was what the climate models should have happened over the time period 1870 to 2010. The climate models are really, really good. Really, really, really good. And that's really, really bad because the climate models tell us there's these various paths, emissions paths that are based not on how Earth changes, but on how humans change. So like the RCP 4.5, we act rapidly to reduce greenhouse gas emissions, and we can keep, well, we still exceed 2 degrees of warming. In fact, all of these exceed 2 degrees of warming. This is the path that we're on. In fact, I don't think this accurately models the 8.5. And the 8.5, the numbers, I'll say this again, but review. The numbers, the 8.5, the 6.0, the 4.5, that is additional watts per square meter of warming for Earth. So the RCP 8.5 assumes that we've put enough carbon dioxide into the atmosphere to warm us by 8.5 watts per square meter. This is the business as usual. This was kind of their worst case. They said, well, how much fossil fuel could humans really burn if they put their mind to it? And that was kind of their worst case scenario, and it's underestimating how much fossil fuels we're actually burning. So as you're watching the videos, 8 Fahrenheit, I think, is a very, very realistic estimate by 2100, 8 Fahrenheit. 5 degrees Celsius, 8 Fahrenheit by 2100. So as you watch some of the other videos, like David Wallace Wells, especially David Wallace Wells, talking about the idea that we can stay at 1.5 degrees of warming or 2 degrees of warming, I think it's going to be much more than that. Yeah, how do we know? So this is an old figure, almost 14,000 peer-reviewed climate articles, and now it's an old study, 1991 to 2012. There are 24 studies that rejected global warmings. I just read a reanalysis of those studies. They tried to go and duplicate the results of those studies, and there were errors in each and every one of them. So the 24 papers that rejected global warming actually turned out to be bad papers. They actually had fundamental flaws in the way that they were doing the research. Yeah, so I guess that makes it, 14,000 to 0 actual scientific articles about climate change. All right, that was the summary version of the summary version of the summary version of the article. And I don't want to waste your time, but I thought I needed to share a couple thoughts on climate change. One of them is the idea that this is the new normal, that we need to think of, oh God, yes. Don't think of this as the hottest summer of your life. Think of it as the coolest summer for the rest of your life. think of this summer as the coolest summer for the rest of your life. The temperatures are going to continue to increase over your lifetime, barring some sort of radical transformative change. PG&E, the public safety power shutdowns, are a new way of life in Northern California that we have just sort of adopted without public discussion. PG&E says, hey, if it's windy, we haven't done proper maintenance on our power lines because we are too busy giving out executive bonuses. So if it's windy, we could start a fire that would cause us to get sued because people are going to die. So we're just going to shut off the power to entire counties across California for, I don't know, days. So get ready for that. And it's just the new normal. The drought. I agree with many scientists who say we shouldn't think of the current hydrological situation that California is in as being a drought. A drought implies that it's exceptional. A drought is the exception to the rule. The current status of rainfall in California is this is new normal. We have shifted. It is hotter, and just because it's hotter, there's more evaporation, so we're going to have more droughts. 6 years is the amount of time it takes for things to become normal, which is a really scary idea. It's kind of like the frog in boiling water, which actually you can't do. The test was actually to see what happened to lobotomized frogs. So if you cut up a frog's brain, you can put it in water and raise the temperature and they don't jump out. But it takes 6 years for humans to adjust to whatever, and it's just the new normal. So the wildfires that we've been experiencing over the last several years, in a couple, I guess 2 more years or so, it'll just be the way it is. Every year we have fires that mean that you can't exercise in the fall and you shouldn't go outside without wearing your N95 mask because otherwise you're causing lung damage. So the drought, excessively hot conditions, extreme rainfall events, all of those things people just sort of adapt to and just move on with their lives and forget that it was at one point exceptional, and it is exceptional. It's unprecedented. Climate change in a lot of ways is very similar to COVID. The whole situation around COVID and climate change, we've known for a long time about climate change. When you start watching the videos, you'll see that scientists have known for 200 years that carbon dioxide and climate change are intimately related. COVID, pandemics have been studied and predicted, and if we had responded differently into this country, we would have saved hundreds of thousands of lives, but we didn't. We delayed. The poor in this country really have had the hardest time. Study after study after study has shown that the poor in this country are much worse off during COVID, under COVID, than the wealthy who can afford to have things delivered to them. They don't have to go into work anymore, for example. And climate change is going to be exactly the same. The people who are going to be hit the hardest are the people who are already in precarious economic situations. The poor, the economically disadvantaged are going to be the people who are going to be affected the most by climate change, not only within countries, but across countries. We've already seen this with the arrival of migrant caravans from Central America as the result of political instability made worse by climate change. Some of the other videos mention that in fact, David Wallace Wells mentions that the civil war in Syria, one of the contributing factors was climate change. The Pentagon, for years, has been putting out studies warning of the dangers of climate change making worldwide conflict even worse. So there's a lot of parallels between the way we deal with climate change and the way we've dealt with COVID. And I would also say that both COVID and climate change have the same sort of political affiliation, that if you want to know what somebody thinks about climate change, or if you want to know what somebody thinks about COVID, probably the best predictor is their political affiliation. And it hasn't always been that way. It's a relatively recent phenomenon. It started with the fossil fuel companies trying to discredit scientists with climate change so that they could keep making record profits. As a result of that, an entire generation of people grew up thinking, oh, scientists are idiots. They don't know what they're talking about. And so with the COVID outbreak, people again said, well, that's just your feeling. or this is my feeling, as opposed to actually listening to the scientists who knew what they were talking about. Speaking of people knowing what they're talking about, this is a graph showing amounts of carbon dioxide in the atmosphere and temperature increase in degrees Celsius. Let's see, 2021, we should be someplace over, well, that would be about 400. So 418 would be right there. So Exxon, I'm sorry. This is an Exxon graph. This is an Exxon graph from their climate change research that they have been doing since the 1960s. The fossil fuel companies have known all along that they are responsible for the vast majority of climate change. And then they lied their asses off. And it's going to be very interesting moving forward as lawsuits start to accumulate. Many people think it's going to be similar to the tobacco industry, where they knew of the dangers of lung cancer and they covered it up and they lied about it and then later got caught. The same thing is true now, where we have documents from Exxon showing that they were well aware of the effects of carbon dioxide changing the climate. And in fact, their own research is right in line with the research being done by NASA and the best scientists in the world. So Exxon has known all along. The fossil fuel industries have known all along that they were causing climate change. Adaptation is an important thing about climate change. I'm not really it's not really addressed a whole lot in the textbook, but this means changing. How do we deal? The climate's changing. How do we deal with this? How do we keep people cool during heat waves? How do we adapt to places that might have been frozen year round, but now they're beginning to thaw out? So adaptation is a big part of it. Changes to infrastructure are going to be huge and expensive. For example, Houston, with the hurricanes that they've seen, as the climate warms, the atmosphere is warmer. A warmer atmosphere can have more water vapor. More water vapor means that you have larger rain events. And so civil engineers, when they're designing cities, they design things like storm drains and roads. And those designs are based on assumptions about the world. And some of those assumptions are, how do you design roads? Or rather, when they design the roads, they assume that there's going to be a maximum rainfall. You can only get this many inches of rain in an hour. So we have to design the roadways to safely drain off, I'm just going to make up a number, 2 inches of water per hour falling from the sky. So that works just fine, except now the climate's changed and now places are seeing much greater, heavier rainfall events. And so the storm drains aren't built to handle it, and the roadways aren't built to handle it. So when you get a storm event that, for example, has it's got 4 inches of rain per hour now, suddenly your infrastructure, your freeways, they're lakes. Mitigation is very similar to adaptation. How do you lessen the blows? How do you lessen the impact of climate change? These are two areas that are going to be critically important moving forward, because we're not going to be able to stop it. We're just going to be able to slow it down and deal with it. Feedback loops and tipping points are key to understanding climate. I think feedback loops, at this point, everybody should be good with feedback loops and tipping points. A tipping point is a point at which a system undergoes radical change. Something changes gradually, you come to the threshold and the tipping point, and then there's radical change. Also called nonlinear. And in the Stefan Rahmstorf video, you'll see he talks about a kayak as an example of a tipping point, that if you're sitting in a kayak, you can lean over a bit and the kayak will resist tipping. So you can lean over a little bit and it'll right itself. You can lean over a little bit more and it'll right itself. But as soon as you lean too far, the kayak flips upside down and goes to a new state. And I think that's a really great analogy for climate, that you can nudge it a little bit and it'll recover, nudge it a little bit more and it'll recover. But if you nudge it too much, it flips to a new state. In fact, I'll put in the announcements, there's a bunch of articles about the Amazon rainforest, which many of us grew up thinking were the lungs of the planet. Well, it turns out as it gets warmer, with more carbon dioxide. As the carbon dioxide levels increase, plants grow more rapidly. But as it gets warmer, plants can't operate as efficiently. Plants like cold evenings. If it gets too hot, the rate of photosynthesis slows down. And in fact, what has happened to the Amazon, it is no longer a net sink of carbon where it's absorbing more carbon. It is now a net releaser of carbon. The Amazon rainforest is actually releasing more carbon dioxide than it's taking in because of climate change. And there's a very real danger of a tipping point in the Amazon. Those of you that have seen the Rivers in the Sky videos know what I'm talking about, that the rain that falls in the Amazon is from the Amazon. It evaporates off the leaves, transpires off the leaves, evaporates off the ground. The water condenses into clouds. That rain falls back on the Amazon. It's a very, very local hydrologic loop. But as the Amazon warms, it could flip and become an arid environment. Once a threshold is crossed, the system keeps going. So I think this is one of the greatest things, the greatest misunderstandings about thresholds and tipping points. So I think of it as like trying to push a bus or an 18-wheeler that well, if you and your friends tried really hard, you could probably get it to barely move. And if you kept pushing, you could probably get it to just sort of trundle along at a couple miles per hour. But if you stop pushing, it doesn't instantly stop. It's going to keep going. So all these tipping points and feedback loops that you'll see, for example, again, in the Stefan Rahmstorf video, once those thresholds are crossed, the system keeps going. It doesn't stop. It's not like if we bring our carbon dioxide emissions to net zero, there's still enough carbon dioxide that we've put in the atmosphere to guarantee continued warming for centuries. Bus, yeah. Stefan Rahmstorf described our current climate situation as if we're running towards the edge of a cliff in the fog. That we know the edge is out there someplace, we just don't know exactly where all of the edges are. And, for example, this is showing, well, it's Camp Century. You'll see this ice core in the Willie Dansgaard video, but the surface of Greenland is about 10,000 feet above sea level. There's about 10,000 feet of ice. So as you know now, it's cool to be high. So the higher your elevation, the colder the air is. So the air 10,000 feet above sea level is much colder than the air at sea level. As the Greenland ice sheet is melting, as the ice on top melts, the elevation of the sheet gets lower, and so it's in warmer air, so it melts faster. So the ice surface is lower, so it's in warmer air, so it melts faster. So the ice surface is at a lower elevation, so the air is warmer, so now the ice sheet melts faster. And there's evidence that we might have already crossed that tipping point with regard to the Greenland ice sheet. So once it starts melting, once it crosses that threshold, once it reaches the tipping point, it's just going to keep melting until there's nothing left, because there's nothing to stop it. The more it melts, the warmer the air is. It's a positive feedback loop. The more it melts, the more it melts, the warmer the air is. The faster it melts, the lower the elevation is. The warmer the air is, the faster it melts. Another idea is that these tipping points in the systems are all connected. I stole this from the Stefan Rahmstorf, so he was talking mainly of the Greenland Ice Sheet and also kind of bringing in thermohaline circulation and the Gulf Stream. But all of these in yellow, coral reefs, the West Antarctic Ice Sheet, alpine glaciers, Arctic summer sea ice, the Greenland Ice Sheet, all of those are tipping points at 1 to 3 Celsius of warming. We might have already crossed the threshold for the Greenland ice sheet. We might have already crossed the threshold for thermohaline circulation to decrease. Other feedback loops then. So if the Greenland ice sheet starts melting, that's going to raise sea level. As the Greenland ice sheet melts, it's going to expose bare ground, which is going to warm up and cause it to melt faster. The same thing's happening in the West Antarctic ice sheet, that it's melting. So as it melts, the planet warms, which then puts more stress on the other systems. So the Amazon could flip to a desert. They're all connected. They're not just operating alone. And so one of the dangers is that as each of these systems fails, it puts more stress on other systems with regards to Earth systems. Which brings me to climate grief. In the comments, a couple of you have already commented throughout the semester that feelings of sadness about the state of our planet are difficult, and I agree completely. This year saw the release of the sixth report. The International Panel on Climate Change, the IPCC, put out their sixth report on climate change, and it's exactly the same as the past 5. Humans are changing the planet. It's going to be bad, and nothing has really changed at an international level, or rather, nothing has changed enough to actually stop climate change in a serious way. There's a lot of lip service, there's a lot of talk, but nothing's really happening. And it's a huge issue for climate researchers who know what's going on, and they're studying it. They're studying glaciers that are melting away. They're studying ice sheets that are actually floating in the ocean in Antarctica. The Larsen B ice sheet, for example, had been there stable for over 10,000 years, and it broke up in a matter of days because of climate change. And the researchers actually had to get air evacuated out because it broke up so quickly. And there's an account of one of the researchers looking back at the ice sheet with tears in his eyes because he realized what this means for the planet. He realized how rapidly the planet is changing. And so I put 2 articles about grief, climate grief, into the announcements. I thought it was interesting. I just I'd seen articles for a while, and I'd been saving them and bookmarking them. And I thought, did I bookmark that same article twice? But it turns out to be no. It's 2 totally different articles recently about climate grief and how researchers deal with that. And some of them have just stopped studying climate. They've gone to an entirely different discipline, and others are dealing with it differently. So I think that's a great article to read. If you're looking for something that isn't super depressing for a discussion post, you could read the articles on climate grief. Yeah, I've taken up enough of your time. I hope you learn a lot in the climate chapter. I hope it's not overwhelmingly depressing for you. Yeah, that's about all I got.